The present video is aimed at providing a brief introduction to the idea of probability calculations using probability distributions of the discrete and continuous nature. And it is a presentation about those concepts and not necessarily about its mastery. In this presentation, we expand a little bit more about probability distributions. They are characterized by certain measures. Talking about the parametric distribution, we recall that they have a probability mass function or a probability density function known as f of x. And using that, we can calculate the following parameters. The mean for discrete distribution is given by this summation. For continuous distribution, the mean is given by this integral. The other parameter that characterizes the distribution is the variance, which is given by this expression for discrete distributions, and by this integral for continuous distributions. The standard deviation, on the other hand, is just the square root of the variance, whether the variables are discrete or continuous. But to calculate probabilities in discrete distributions, we're going to provide a series of formulas here. The probability of x equal x is the PMF. For less than or equal to x is the CDF. And then for less than or the x is equal to the CDF of x minus 1. For x greater than x is 1 minus f of x. And for x greater than or equal to x is 1 minus f of x minus 1. In the next page, we're going to present the calculation of probabilities for discrete variables for different intervals. And we have the first one here. Here's the second one, the third one, and the fourth one. Basically, we have contemplated here every possible situation, like less than in the first one, less than or equal in the second one, less than or equal in the first one, less than in the second one, and less than or equal, and less than or equal in both of them. If this is for the case when x2 is greater than 1 from x1, and this is for random variables that go 0, 1, 2, and so on. If x2 is just x1 plus 1, that means the next one, the first case is 0, the second one is f of x2, the third one is f of x1, and the fourth one is the sum of the probability mass function of the two of them. This is in terms of this diagram, where this arrow represents the f of x2 and this small arrow the f of x1. And so here you have the different intervals and what points are included in each one of those intervals. For continuous distribution is simpler. If we given a probability density function and the cumulative distribution function, we know that the probability of a point value is 0. For x less than x is the cumulative distribution function. For greater than x is 1 minus the cumulative distribution function. And for an interval is just the cumulative distribution function at the second position minus the cumulative distribution function at the first position. In terms of graphs, the probability mass function for a discrete distribution looks as a series of vertical lines. And that's because at every point, the probability is concentrated around that point. And then the cumulative distribution function, it's a cumulative value that remains constant until the function hits the next value of the distribution. For continuous distribution, the PDF is a continuous curve, and the cumulative distribution function is an increasing curve that reaches the value of 1 up here. And with that, we conclude this presentation.